Hi, everybody. Thank you so much for joining us. Some of you we've seen most of the day. Some of you have popped in special just to see our keynote speaker. We are very excited to, one, have you here. This is our third and final virtual conference of the year. So thank you for being in attendance. Thank you for fighting Zoom fatigue with us and learning even virtually. I would like to do a couple of quick plugs, so if you'll forgive me, that we have a lot going on for the Virginia Association for Environmental Education right now. If you were not aware, we have our in-person conference in February. That'll be at the Airfield 4-H Center, which is in Wakefield, Virginia. That is February 24th. We do have a request for proposals open. It closes October 29th. So if you're thinking about submitting a proposal, we would love to hear from you. We also are having some board turnover this year. So you can always check out our website or check us out on social media to see the positions that are open, as well as nominating yourself or others. We have an open house on November 10th. Bruce put it in the chat if I said it wrong. November 10th. So you can check that out. We'd love to have you. It's a Q&A for board positions. So that's just a little bit of housekeeping. We are really, really excited. I am, because I am also with Friends of the Rappahannock, as well as the chair-elect for VAEE. And we care so much about our waterways. A lot of what environmental educators do is meaningful watershed educational experiences. And we all live downstream. So even though this is fall in the Piedmont, we know that all of our rivers flow downstream and end up at the coast. And so we're really excited today to have Bo Lusk with the Nature Conservancy here to share some of his work as a coastal scientist. So Bo, thank you so much for being here. We're really excited to have you and learn from you today.
Awesome, thank you. Thanks for the introduction, and thank you to each of you for taking some time to be here with me this afternoon or evening. Maybe it's happy hour. Let's say spending your happy hour with me. I hope that's what it is. In any case, I want to thank you all also for doing what you do. I really love my job doing marine habitat restoration for the Nature Conservancy, and a big part of what led me to this job is all the different environmental educators, whether they knew who they were or not, that I encountered over the course of my life. They shared a lot of passion for the environment with me, and they didn't guilt me into doing better. They didn't ram a bunch of facts and figures down my throats. It was really their sharing their passion for the environment that sort of led me down this path. And today we're going to talk about oysters and seagrass and probably some bay scallops, and I will give you a bunch of facts, but what I really want you to take away from this is the fact that there's some really special stuff happening right here in Virginia. Some really world-class restoration work that is good news and is being shared beyond our borders here in Virginia, shared all over the country and around the world. So some fun stuff that will hopefully inspire you. Let me see if I can figure out how to get this thing going. So as I said, I work for the Nature Conservancy, and we are a private nonprofit, and we get really the vast majority of our funding through private donations, although a lot of my work is through federal and state grants. And are you guys seeing presentation view?
Yep. Oh, not presentation view yet. No, just the slides.
Got it. Let's see. So you're seeing like presenter view?
No, this is now, we're seeing speaker view, I think, at this point.
Okay. Oh, man.
Maybe go up to display settings. I don't know.
That's what I'm looking for. Turn that off.
If you go up to the top to slideshow, maybe.
Sorry, this is so inspiring. This is exactly what I wanted you to be seeing. Bruce, what can you kind of?
Yeah, so right, if you go up to your toolbar, next to animations, there's a slideshow. So up, right there to slideshow. Right, you're almost there. Up one more level.
Yeah, so I'm seeing all my Zoom controls are covering it. That's what's happening. Maybe I can make that smaller. Darn it. Well.
Or you can just present it like that, and that works for us.
All right. It's not going to do any of my animations here, but we can work through it.
Or if you stop share screen and then maybe go to present and then select the screen as it's presenting, that might be a better way.
Cool. What have I done here though? What is it? All right. Sorry, gang. I'm almost there. Okay. Working okay now?
Now, if you'll share your screen, then we'll be able to see it.
Thank you for bearing with me.
We're still not seeing the slideshow view. If you go down and click that, yeah, that present, maybe that will get us there.
Cool.
Just take it at sweet time.
I don't have any notes, so. All right, let's go with this. Sorry about that, you guys. If you can see the screen here, I want you to see that I work for the Nature Conservancy's Virginia Coast Reserve, and I just wanted you to make sure you understand where that is. Right now, we're seeing mostly the Chesapeake Bay, sort of in the center of the slide. And then to the right of the bay is the Delmarva Peninsula. And then the skinny part of the Delmarva Peninsula, all the way down to the bottom, is Virginia's eastern shore. It's the part that gets left off of a lot of maps of Virginia. And I grew up down near the southern tip of that, near Cape Charles on Cherrystone Creek, which is the creek where my dad grew up, and my grandmother grew up, and even to her grandfather grew up there. So I grew up on the bay side of this peninsula, but I grew up playing very frequently on the Atlantic Ocean side of the peninsula. And that's what's circled here in red, this system of barrier islands and seaside lagoons. So that's where I work, not Chesapeake Bay, but over here in the Atlantic coast. And this is where the Nature Conservancy protects all or part of 14 barrier islands. And the rest of those barrier islands are also protected by the Fish and Wildlife Service or the state. So we've got this long stretch of protected, relatively pristine barrier islands here, and really nice water quality in the coastal bays between them and the mainland part of the eastern shore of Virginia. And there in that system is where I work to restore oysters and to restore eelgrass and a little bit to restore bay scallops into that. And I figured we'd start off by talking about sort of set up the problem. What went wrong? Why do I even need to restore it? And the system was a lot different when my grandmother was born in the early 1900s than it was when I was born in 1975, and it continues to change today. But in the early part of the 1900s, we had eelgrass growing all over the system. And we don't really have a good number on how much eelgrass was there, but we do know that a bay scallop fishery developed there. Bay scallops have to have eelgrass to live, and we'll get more into them a little bit later. By 1930, Virginia was the leading producer of bay scallops in the United States. And we don't typically think of Virginia for bay scallops. They're typically a New England thing, and there's some in Florida as well. But we were a big deal then. And that's the industry that my grandmother remembered from when she was a teenager. But there was a problem. During that time, there was a slime mold that was infecting eelgrass all over the North Atlantic, not just here in Virginia. Europe, New England, and it was particularly hard on our grass here. And that wasting disease, that slime mold, combined with a big unnamed hurricane in 1933, wiped out all of our eelgrass on the seaside. So we went from having eelgrass everywhere and this huge bay scallop fishery to no eelgrass, which means no scallops, and we completely lost that fishery when my grandmother was a little girl. So that was a big change in the early part of the 20th century. But we still had oysters. We had people fishing oysters all over the seaside. Our maximum oyster harvest for the Atlantic coast of Virginia was about 500,000 bushels a year, and that was in the 1950s. But at that point, we got hit with a couple of diseases. We got hit with a non-native disease called MSX, which made our native disease dermo even worse. And those diseases really wiped out our oysters. Any oysters that did still grow and made it through the diseases were harvested because people needed to harvest oysters to make money. And by the 1990s, our oyster fishery really bottomed out with just about 500 bushels total coming from the seaside of Virginia's eastern shore. So a major loss of all these eelgrass meadows and a major loss of all these oyster reefs. It was a big, big change in the system. And it wasn't really until around the turn of the century that a bunch of us got together to start to figure out how to fix that. And that's the Seaside Partnership. I'm going to say we a lot of the time in this presentation. And when I say we, I don't just mean the Nature Conservancy. I mean a lot of our partners, whether it's the Virginia Coastal Zone Management Program or the Virginia Marine Resources Commission or the Virginia Institute of Marine Science, or the loads of volunteers that work with us. So I'm going to shortcut to we a lot of the time in this. But this partnership that started in 2001 has really reversed things. And for me, being born at sort of the, after the bottom of the oysters and after the loss of eelgrass, my daughters who are growing up here are starting to see things really on an upward slope instead of a downward slope like I saw, like my dad saw, or like my grandmother saw. So the first part of this, I'm going to just focus on oysters, and we'll switch gears to talk about eelgrass and bay scallops later. But I want to start off real quick why it even matters that we lost those oysters. Right here, we can see someone's holding an oyster shell, and there's lots of little baby oysters growing on it. Those are spat. And the way oyster reefs grow is generation after generation, new oysters grow on top of old oysters. And by doing that, they make these really complex structures that we call oyster reefs. And those reefs are really important habitat. They're important for a lot of the fish that we like to catch and eat. And if you've got other fish that don't use those reefs as habitat, those fish probably at least eat some smaller fish that use those reefs as habitat. So they're really important for fish and for crabs. And while they're being habitat, oysters are filtering water and they're clearing the water, which helps make it easier for plants to grow, like the eelgrass we'll talk about later. And in that filtering, they remove all the extra fertilizers, all the excess nitrogen from the water, whether it comes in runoff from ag fields or from our yards or from our stormwater. Oyster reefs, it turns out, are really good at getting that nitrogen, the bad form of fertilizer, out of our waterways and back up into the atmosphere where it belongs. And we've also discovered that if we build oyster reefs the right way, they can actually reduce a lot of wave energy, and oyster reefs can be really helpful with preventing or slowing down erosion too. And then lastly, don't forget, we care about oysters because people like to eat them and people make money from growing them. So that's just as important as any of these other reasons to care about oysters. But to understand how we restore oysters, you need to understand a little bit about how they work. So these oysters at the bottom left are spawning. And oysters spawn in Virginia about the middle of June, and they'll have a few more spawns throughout the summer. And their sperm and eggs go together to form these little free-swimming larvae that float around largely just at the mercy of the currents for 2 or 3 weeks before they go through a final metamorphosis and need something hard to settle out on. And I will call that a lot in this talk hard substrate, because that's a big part of my job, is getting substrate overboard, hard surfaces for these oyster larvae to settle on and begin to grow into something that looks more like an oyster than these weird looking larvae across the top of your screen. Those baby oysters are called spat, and they will grow for a few years to become adults. But an interesting thing about these oysters is in their first 2 years, maybe longer of life, they're all boys. They're all born as males, and it's not until an oyster becomes a little more mature that some of them switch over to be females. So it's also important that we have lots of different age groups, because if we have just a bunch of oysters all the same age, they're probably just a bunch of dudes, and we're not going to make more oysters in the system. So one more consideration for us here. And where I work on the seaside in these coastal bays is a little bit different than Chesapeake Bay. And for anybody that does restoration of oysters, you really have to understand how oysters work where you work. We are lucky in that there were enough oysters on the seaside that made it through the disease and the overfishing. A few isolated clusters that were maybe hidden back in the marsh and no one got, that some disease tolerant individuals made it through. And as they continue to reproduce, we get some oysters that are pretty tolerant, and they don't die of that disease, which is fantastic. It means, like I said, all I have to do is get culch overboard. That's other shell or other hard substrates. But I have to put it in the right place. On the seaside, all of our oysters come out of the water at low tide. So mean low water is about as deep as our oysters are going to get. We don't have actual subtidal deeper water oyster reefs like we do in Chesapeake Bay, which I love. I get to see my babies every time I go out at low tide. I can actually lay eyes on them and see how things are going. So I've got to get my oysters in the right area of the tidal column. And like I said, we still have some disease around here, but it's not killing the oysters so quickly, and the oysters can reproduce and sustain themselves. We work mostly with VMRC, the Virginia Marine Resources Commission, to do this work. And you know, some of these first reefs were built back in 2001, and this is after that bottoming out of the fishery in the 1990s, when we didn't think we could even really grow a functional oyster reef. And so we were just planting shell to see if we could make an oyster grow, and maybe it wouldn't die if we could keep people from harvesting it. And it's worked. You know, we've planted a bunch of acres of shell over the years. What you're seeing there on the left-hand side is a pile of shell that's dredged from a paleo river valley deep in an inlet here on the seaside. So that's where ancient river mouths used to empty into the ocean. And there's old oyster shells that are so deep they can't grow new oyster reefs. We dredge them up to the surface, and then we blow them off of those barges with big fire hoses onto intertidal bottom. So they're working that boat at high tide, blowing those oyster shells overboard. And at low tide, that shell would be exposed. And after a few years, what you see is on the right, a nice, healthy, living reef. These oysters are really doing well. You can see it takes a lot of shell to do this. Different sized boats doing this work. And because we invest so much in it, we need to monitor these oysters to see if what we're doing is working, how it's working. We go out and we take samples and we count the critters we find in them. We measure and count the oysters. The top right picture, we had to break ice a few years to get to our samples. And we have a really long data set, over 15 years of monitoring data, which is the most continuous oyster monitoring data set that I've found anywhere in the world. And those numbers are telling us that this stuff really works. We do have a few sort of ideal oyster reefs out here that we didn't have to build, that we can measure our restored reefs against as a reference. And we're finding that it really only takes about 7 years after we put shell out for our restored reefs to function at least as well as these model reefs that we have out there. So this monitoring is telling us that what we're doing really does work, and we can relatively quickly, within 7 years, start to restore an oyster reef. We do that over acres and acres of bottom, largely to restore habitat here. But as there's more and more interest in coastal resilience and protecting against storms, we've started to build a lot of oyster reefs more with the idea of protecting land, not just to filter water, not just to be fish habitat, but can we protect our property that we live on and care about? And so we want to see if we can work oysters into living shorelines. Because what's cool about these oysters is that since they grow on top of each other, that reef can grow vertically really just as fast or faster than sea level rises. Those oysters have to be in the water, so they won't grow above mean sea level. But as sea level continues to rise, any wall that's living and made out of oysters can grow upwards apace with that. So we're looking for ways to work oyster reefs into living shorelines to have a wall that will continue to protect a shoreline over time. And in order to do that, it helps to have a three-dimensional reef. So for protecting shorelines, rather than putting these old oyster shells out flat on the bottom, we use alternative substrates. That's really just any hard surface that isn't a shell that happen to have some vertical relief to them. And one of our favorites to use here is an oyster castle. It's a concrete block that you see pictured on the left. They're about a foot on each side, 8 inches tall, 35 pounds or so. And we can put them together like Legos. And best of all, we can involve a lot of volunteers in that work. There's a lot of castles to carry around and to put together. And we use loads of community volunteers to help us with that work, which is really rewarding for me, getting to work with our general public. It gets all of our volunteers and more of our community more invested in our project, caring about it. These volunteers come to help us out, already caring about oysters some, but once they've really put in the sweat on this, they're really interested in oysters from here on. So to the right, you can see some of these castles we put together at Chincoteague National Wildlife Refuge. That's along the road out to Assateague Island there. And within a few years, those blocks really do become covered with oysters. Those oysters are growing up and they're helping to protect that marsh along the side. And what you see in the bottom picture is some marsh that's actually even expanded out. So by restoring oysters, we're in some places even restoring a little bit of extra marsh that grows right up through these castles once that bottom is protected. So we use a lot of castles, lots of volunteers helping us with this. And we're starting to use a new substrate here that's that involves volunteers a whole lot, and that's Sandbar Oyster Company materials. And the Sandbar Oyster Company materials work in some places where the bottom is either too steep or too muddy to use those heavy castle blocks. And this is these are made just by taking a jute material. It's a plant-based mesh that's used in erosion control very often. You might have seen it put down on the ground to hold grass seed. And we soak it in cement. And once this stuff is soaked in cement, we can mold it into a bunch of different shapes. You see some stick-like shapes there at the top, both before oysters were growing on them and after. We can make some log-type shapes that you see at the bottom that are particularly good at holding mud and sediment in to help protect the shoreline. And the volunteers will help us put those materials out in the marsh. But we have a lot of volunteers who really aren't up to walking around in knee-deep mud. And so we can utilize those volunteers just by coming to help us work with cement. So we have a bunch of folks helping us make these materials, and then a whole nother group of folks helping us deploy these materials. One of the main shapes we're making now is this table you see to the right. It's about the size of a little end table. And those legs of that table will get pushed down into the mud, but the top will float up off the bottom where oysters can grow both on top of it and underneath of it. And these are being used on a few projects around, one in Watchprig, Virginia, up here on the seaside, which is a low-lying coastal town that is really worried about coastal flooding, but also worried about a marsh that's eroding, because if this marsh erodes, they can't be protected from waves and big storms. So we can put things along some of these edges. Here's some tables here, and help to grow oysters. At the very least, if nothing else works, we're going to grow more oysters at this Watchprig site. These are tables stacked with their legs interlocked. And at the bottom, though, you see some tables that are just a year old, and that's spat. Those are thousands of baby oysters growing on those. And what we're finding is that these oysters are growing up well, and that these new reefs are helping to actually hold a lot of mud on the backside between that marsh and these oysters. And we're starting to see some wave attenuation from these. So hopefully this project, besides just growing oysters, is going to really help to protect this marsh. And if this marsh stays wide and healthy, then it'll be there when we have big storms, when we have hurricanes, because tide goes up in a hurricane or a big northeaster, and the big waves that come rolling in aren't really affected by the oysters deep down underwater, but that big healthy marsh really helps to take the punch out of those waves and helps to protect our friends in the town of Watchprig.
We have a question real quick, Bo, about the
This is
tables.
a good time for it.
Do you have any issues with fishermen or anyone else tampering with the oyster Legos or the tables at all?
You know, back when we first started, and I've been doing this since 2007, so I'm going to speak a little bit about stuff that happened before I started. But so 2001 to 2003, those early reefs that were built out of shell had a lot of poaching. In fact, I think the first grant we got from NOAA to build reefs, in our first grant report, we had to tell them we thought that, you know, 10,000 oysters had probably been stolen. And we were really worried NOAA wouldn't give us any more money. But things were things were so dire that NOAA was actually elated to know that we could even grow that many oysters worth stealing. So they continued to fund us for years. So we're fortunate now in that oysters are doing so well on the seaside that we are probably growing more oysters than anybody's going to steal. And part of that's because oysters are doing better and better and better. And part of it is because the culture of oyster poaching is starting to die off. Some of those folks are getting older. A lot of the folks in wild oyster fisheries around here are doing oyster farming instead of harvesting wild oysters. So I would say no, and particularly for alternative substrates, for castles and this new stuff, I have not really witnessed much, if any, poaching. It's not been as big of a deal. But we do still have some poaching on the shell plant reefs that we do. Good question, though. It's something we used to put a lot of energy into patrolling reefs and putting up signs and trying to catch poachers. And I think we've turned a corner. It doesn't mean I don't care about it or want to stop that, but I think it's not worth putting the energy into that right now. I can make more oysters if I take that energy and put it into building more reefs. Good question. We're going to switch gears now to eelgrass. So I talked about eelgrass that we lost even earlier in the 20th century. That was gone in 32 or the 1933 storm. Seagrasses are these underwater flowering plants. If you've never seen a big seagrass meadow, just picture a meadow or a prairie and put it underwater. That's a seagrass meadow. It's pretty big. They grow all over the world. There are 72 species of these things around the world. The only species of seagrass that we have in Virginia is eelgrass. It's the only one we're really supposed to have here. We have other types of subaquatic vegetation, but they don't need full ocean salinity like seagrasses. So here on the seaside of the Eastern Shore, really the vast majority of what we're going to see is eelgrass. And seagrasses aren't doing so hot. They've been declining. We've lost 29% of them since the 1800s. So the total loss we had here isn't that weird. And that rate of loss is getting even worse. So since 1980, that rate has increased where we're losing a football field worth of seagrass from our planet every half hour. So if we talk together for an hour, that's 2 football fields gone from the planet. But Virginia is really one of the only places in the world where we can say that's absolutely not true. We're seeing a lot of success with that here, and the rest of the world is starting to take notice of that success and be inspired to try to buy it to try to fix their seagrass loss issues. So again, why do we care about eelgrass? We talked about all the things oysters do for us. We need to talk about eelgrass too. And like oyster reefs, it's habitat. It's habitat for the fish we eat or for the fish that those fish eat. It's where crabs like to hide. Blue crabs go to shed and are soft, defenseless crabs for about 4 hours. It's a great place to hide. If we had Virginia bay scallops, that's where they would live. And besides being habitat for living things to live in, it's food for other living things. So in the winter, when we have diving ducks and brant migrate down the coast, they feed on the eelgrass too. And when we lost our eelgrass, we lost a lot of our brant population or the seaside flights of diving ducks. But besides just helping these living things, these biological things, it does a lot of physical work for us too. Just by being this big carpet in this area, it holds that sediment in place. So eelgrass grows in relatively shallow water. It's got to be shallow enough that we get enough sunlight penetrating down so that the grass can grow. And these shallow waters, if they don't have eelgrass on them, it's just a mud sand bottom. And as waves roll over that, it kicks all that mud up into the water. That mud ends up filling up our navigable waterways, or it ends up covering our oyster reefs and our oyster substrate. So just by having this big carpet of grass there, it helps to keep that mud where it belongs. And then again, as the waves roll over top of it, it absorbs wave energy. So if you imagine rolling a ball down a hardwood floor hallway, it doesn't take much of a push to make that ball go all the way down to the end of the hallway. But if that hallway instead had a big thick shag carpet and you push the ball with the same amount of force, the ball wouldn't go very far. That friction really absorbs a lot of the momentum from that ball. Well, the friction of this grass absorbs a lot of the energy that's stored in these waves. And by having big, wide underwater meadows, we actually help to slow down shoreline erosion because the waves rolling across these seagrass meadows aren't nearly as powerful. They store a lot of carbon. All the particles in the water, you can see this isn't a perfectly clear water that this grass is in. These particles are largely organic matter. Those organic particles settle out of the water column as the water is slowed down through the baffles of these leaves. And the soil of a seagrass meadow can store carbon at a much higher rate even than a terrestrial forest. So they're good for getting carbon out of our system and buried. Another concern is, as we see seawater temperatures increasing, is that the ocean gets more acidic. Locally, that could be really tough on our shellfish, on our clams and oysters. But when you have eelgrass around photosynthesizing, taking up carbon dioxide out of the water, it acts like a big Tums. It's a big buffer for that increase in acidification. So all sorts of things that grass does to help out, both for things that are living in it and feeding on it, and then physically for the system around it. Very important for us. And when we didn't have it at all here on the seaside from 1933 until 1997, the system changed. It was not healthy for it. But we were fortunate. 1997, a couple of patches of eelgrass showed up behind an island called Wreck Island, very small patches. They were reported to VIMS, and Dr. Bob Orth at VIMS came over to take a look. And that really inspired VIMS to start working hard to try to figure out how to restore eelgrass to our coastal bays after it had been gone for 70 years. And what they figured out really here was, traditionally seagrasses had been restored by planting plugs, where you have to grow a baby plant, baby the baby plant, take it into the water, dive underwater, plant it, and just cross your fingers that it grows and lives. That's expensive. It takes a lot of time. And what they figured out how to do here was how to harvest seeds from these plants and restore the plants just by planting seeds. And we didn't have enough eelgrass on the seaside when this project started in 1997. So the first seeds came from some eelgrass beds that happened to still be alive in the near the mouth of the Chesapeake Bay. And after figuring out how to do it, after VIMS figured out how to do this, it became apparent that we needed a lot of helping hands to really scale this up. And that's where the Nature Conservancy stepped in with our volunteer corps to help snorkel around in the spring and pick these eelgrass shoots that have seeds developing in them. And then we take care of those seeds over the course of the summer and plant them in the fall. So now every May, we have plenty of eelgrass on the seaside. We sometimes have 100 volunteers in a year come out with us over the course of a few days to collect these shoots while they're snorkeling, stuff them into bags, and bring them into our seed curing facility. So we take the volunteers out while the eelgrass is growing seeds and they're flowering shoots. And I have to teach everybody just the basics of what they're looking for. You see two eelgrass shoots in the picture we see now, and they probably look pretty similar to you. But the one on the left is a vegetative shoot. That's not what we're looking for. That's just a photosynthesis machine. They're big, long, flat blades of leaves. They're green, catching the sun's light, not making new baby plants. But the one here on the right, you might notice that the leaves aren't quite as long. They're actually a lot more branched. And if you take a closer look at the tips of those branches, they're the seed pods, essentially. In eelgrass, they're called spathes. And they're not flat and smooth like a piece of cellophane tape, which is how the shoot on the left would feel to your fingers. They're bumpy. So if you run your fingers over that close-up that you have there, you feel the actual seeds that you can see there between your fingers. So we snorkel around in the grass beds for a few days, pick as many of those as we can, and we bring them in to our seawater facilities and put them in tanks. These tanks have to be worked over the course of the summer as the seeds finish developing. The seeds are really dense and they'll pop out of those spathes. They'll settle to the bottoms of the tanks. We use our bodies to keep the tanks stirred. Sometimes we use volunteers' bodies to keep the tanks stirred. This is 7 days a week job for us over the course of the summer. And once we think all the seeds have been released, we can actually use essentially a modified pool skimmer to skim out all that plant material from the water column, leaving the seeds down on the bottom of the tank where we can separate them out later. This is how small those seeds are. at the end, really teeny tiny little things. And we collect hundreds of thousands to millions of them each year. This year was a pretty good year between VIM's seagrass seed facility at Gloucester Point and our seagrass seed facility here on the Eastern Shore. We collected about 5.5 million seeds, which is better than we've had in recent years. And these seeds aren't going to germinate until water temperatures drop in the fall. So we hold them, we keep them safe into the summer. And we actually just planted our seeds last week. So we planted 19 acres, just about 2 million of those seeds last week. And it's a pretty simple process. There you can see Bob Orth throwing some extra seeds out, and that's me tossing seeds. We just ride around in a boat and toss the seeds. It's very simple. We have preset plots that we want these seeds to go into, so we try to throw them out in a fairly even manner. And the numbers at the top aren't right. Since we planted 19 acres last week, and we've got a few more acres to plant, so we're over 600 acres planted right now. And those 600 acres are doing really well. In fact, they've expanded all on their own to 9,476 acres. So that eelgrass you can see in some of these coastal bays in red here. This is by far and away the largest successful seagrass restoration project in the entire world, and it's going on right here in Virginia. And people are taking notice. We've had visitors from the North Sea come in to figure out how they can reproduce this there. I've visited folks in Australia, and folks in Australia visited us here to see how they can use this on some of their own native species where they are. Other places that maybe just didn't have the willpower of the government or the money to do it are standing up and taking notice and saying, hey, if they can restore seagrass where they are, maybe we could. I wonder if it would be worth investing the money it takes to do that. And we can start to show them, hey, maybe it is, because we also monitor the fish that are in this. Loads of fish, they're actually using this new habitat that, again, was gone completely for 70 years. It's been measured to see what it's doing to the water quality. So the water in these bays is now more than twice as clear as it was before we started. Those fish that we're monitoring, there's 172 times the fish biomass in these bays as there was beforehand. Does a good job of helping to get rid of that nitrogen like the oysters did. And it's sequestering carbon at least as much as is produced by 653 cars each year. And that number increases because not only are these eelgrass meadows expanding every year, but as they get older, they get better at storing carbon. So there's lots of reasons here that if you convert these into dollars, it may be worth it for your locality to start figuring out how to restore the eelgrass or your local seagrass, depending on where you are on the planet, and put the energy into that. Are we doing on time here? Okay, so I want to talk a little bit about bay scallops. They're sort of part of the eelgrass deal, right? So now that we have almost 10,000 acres of eelgrass, there's enough habitat out there that we figure we might be able to restore bay scallops into the system. So that once again, there's such a thing as a Virginia bay scallop. We had, like I said before, this was a big fishery for us for the 12 years from 1920 to 1932. 33 is when we lost eelgrass. That's when we lost our fishery. But when we led the nation in 1930, that was probably while the eelgrass was already starting to die, and our bay scallop harvest declined from that in 31 and 32. And again, since then, zero commercial bay scallops harvest since then. And this restoration work is really being led by VIMS. VIMS has a hatchery here in Wachapreague, the town that we're doing that oyster restoration project to protect. They've developed a Virginia bay scallop broodstock, and they're really leading this work. We help them out as we can, and we're trying to restore them sort of three different ways. The cheapest and easiest way is to take the larvae that they produce in their hatchery. I'm holding what looks like a dirty tissue there in my hands. That's about 11 million bay scallop larvae. We dissolve them in the water in that bucket and slowly pour the bucket over the side as we drive over the eelgrass beds. That's the cheapest, quickest way to get bay scallops out there, but it's really tough for us to measure if we're doing any good or not. Are they going out the inlet into the ocean, never to be seen again? Are they being eaten by other things? We have no idea. Next thing we can do is to grow those larvae out in the hatchery, which takes some doing and some extra money, and then plant those babies out in the eelgrass. These are the cutest. I wish that this was a video so you could see. These scallops are in my hand and they're snapping. All these little guys are opening and closing, and they seem so excited to be in the eelgrass. And as we put them out in the grass, they spin little threads out of the hinges of their shells, and those threads attach them to the blades of eelgrass 2 or 3 inches up off the bottom. And that keeps that baby safe from being washed out by the tide, but also keeps it from being eaten by crabs that are crawling around on the bottom looking for some food. And as those scallops get bigger and better able to control their movement and better able to, or tougher to eat by a crab, they'll actually drop off of that eelgrass blade and live on the bottom underneath of the eelgrass canopy. But they're tough to track as well because scallops swim around, they can move. They're not like oysters and stay glued into one spot for their whole lives. So what we've done quite a bit of is put these juvenile scallops in cages, similar to how oysters are farmed, and put those cages into the eelgrass beds. Those scallops are protected from being eaten for the most part. Occasionally we get a predator in. We had this octopus get into our cages one winter and it ate every single scallop in that particular cage. But for the most part, these scallops are protected. And best of all, instead of being spread out over 9,000 acres of eelgrass, they're all really close to each other, which is important because when you only have a few 100,000 scallops and they're spread out over all that eelgrass acreage, it's hard to have reproductive success. It's hard to find a boyfriend or a girlfriend. So by having them in these cages all really close to each other, we have a lot of breeding success, and their babies, which are larvae, wind up recruiting into the grass beds. So we know that the offspring of these scallops we put in cages do indeed like living in this eelgrass habitat that we've restored. And every summer in July, we do surveys to see how many scallops are out there as a result of these breeding scallops that we put into the cages. Right now, it's probably not a self-sustaining population. If we don't keep inputting more scallops, I don't know that they would still be around. We certainly don't have enough scallops out there for a commercial fishery or even a small recreational fishery, but we're showing some promise. We're learning a little bit more about this every year, and VIMS is really leading the way on this front. And it's exciting to see this this fishery that my grandmother told me about when I was a little boy, that disappeared when she was a little girl. And she would tell me about the shucking houses and the men who worked in the shucking houses, processing these scallops. All were out of work when we lost our eelgrass. And if we can get it back, this sustainable yield here could help our community out with could be worth about $20 million a year. Even if we don't have a commercial fishery, it could be something for our eco tour guides. You could maybe take some folks out in kayaks and they could hand harvest a few scallops to take home with them. We may be able to find a way to use this to sort of broaden our local clam and oyster shellfish aquaculture industry to have a new product. But it's really fun to see, all the stuff that changed when my grandmother was a little girl that was either gone or declining as my dad grew up and as I grew up, is now headed in the right direction for my daughters, who you see here. I never held a live bay scallop in my hands when I was a little boy. They don't know a seaside without live bay scallops. They don't know a seaside without eelgrass. They know what oyster reefs are and what they're supposed to look like, what a healthy oyster reef looks like, not just a sick and dead one. So there's a lot of hope. There's a lot of good stuff happening here, and we're able to communicate this to you guys today and really to a lot of visitors that come to see us and learn from us from all around the world each year. And I'm really, really lucky that as I was coming along, I had the right environmental educators to help inspire me, to push me into the job that I have now, which I think is really about as fulfilling a job as I could have, helping to restore my family's home, and then helping to maybe work with some really cool people from around the world to figure out how we can help them to do it where they live. And with that, if there's any time, I'm happy to take some questions. Thank you guys so much for listening to me.
Oh man, do you have questions? And of course, folks, if you have questions and you haven't entered them into the Q&A, please go for it. I have not been scanning the chat yet. I've just been looking at the Q&A, but we'd love to get your questions.
And also, feel free to raise your hand if you want to ask your question live, and then I can allow you to talk. So if you would rather ask them live. But let's get started with maybe a few about the bay scallops that we just talked about, and then we can go back maybe to the questions about gillgrass and work our way backwards.
Awesome. So I will start with, one, besides smart, genius octopus that might sneak in and eat a bunch of scallops, what are the bay scallops' main predators?
Well, it depends on their size. So I would say those little ones, those really cute little things, have a pretty fragile shell. It would be easy for me to crush it between my fingers. And so at that size, really any crab can get into it and eat it. As they get bigger, they're more likely to be eaten by rays. And most of the rays that we have are cow-nose rays. I didn't mention those scallops actually have little eyes, and there's 18 pairs of these beautiful little blue eyes that they can't tell what you look like. They really just mostly see changes in light and dark. Yeah. But if a shadow of a ray comes by, that scallop can be alerted and he can swim away from that ray and hopefully avoid being eaten.
Okay, I'm gonna just interject. How fast can a scallop go?
I don't know.
I want to know next.
I've had a few of them swim away from me to where I missed them, but it's not so much because they were faster than me. They were just faster than my eyes. I lost them. I don't like this fast. They go. I like that. That is a great unit of measure. You would think they would typically move back, like if their hinge is on one side, that they would move sort of towards their hinge. But actually they move more Pac-Man style. They squirt the water out of the hinge, and that water propels them forward. And they have a lot of control. If you set one down upside down, it doesn't like to be upside down, and it will jump up, flip over exactly 180 degrees, and land right side up. So they kind of have some control over those jets.
That is so cool. All right, I'm going to keep with our shellfish, our bivalves, real quick. So we had an initial question. I know Chesapeake Bay Foundation collects oyster shells from local restaurants. Do you all use those and recycle them as well?
We do some of that. The way you go about restoring oysters is very different from one locality to the other. And I've visited projects all over the US, all over the world, and it's amazing different strategies different people need to do for where they are. Where we are, we have a great shell source. Those old paleo river beds provide a lot of shell to us. It's pretty easy for us to get to. But the fact of the matter is, there's not enough old shell out there. Oh, there's another good shell source near Kings Mill, near Busch Gardens in the James River too, like that. But it's a little tougher to access. There's not enough shell to do all the oyster restoration that needs to happen. So one good thing we can do is recycle shell. I don't have too much, but I do some. And the other thing we can do is try out these alternative substrates like Castles or like the Sandbar Oyster Company substrates too.
And that does kind of lead to, so someone else mentioned the concrete balls for reefs. Do those, or y'all do those sometimes, or do y'all stick to the Castles?
Those things are great. We castles really were invented because of those. We worked with a high school class from the Charlottesville area that worked with Allied Concrete to make a bunch of those concrete reef balls for one of our projects. They work. They're a lot of work though, packing them. You have to pack the molds by hand. And as a result, Allied Concrete invented oyster castles because they can just pop 5,000 of them out of machines every day. The downside is they're kind of small and you need a lot of volunteers to put them together. So if you need to build a really tall reef, like you might be building in deeper water in the Chesapeake Bay, you're probably better off using a big reef ball. So all depends.
Yeah, that's great. I personally, I don't know, this is a little bit of a tangent. There is a reality show about Legos, right? I can't think of what it's called. That's like Lego Masters. And I was just like, oh, what if they had like an oyster Lego challenge? Anyways, that made me excited. So again, y'all, I see the eelgrass questions. I'm coming back to them. Don't y'all worry. So we had another thought of, it's awesome that there's so much volunteer engagement. What is the most helpful thing that someone interested in supporting oysters, or maybe even scallops, can do?
Good question. There's scallops are tough. At this point, there's really not a lot to do for scallops, except be excited about them and tell people about them. The oyster work is we pretty much always have projects going on with oyster castles and the oyster catcher substrates. And if you wanted to help us, you can sign up to be a Nature Conservancy volunteer and come help us when you get a chance. The castles are kind of heavy for a lot of people, and walking in mud's not always easy for folks, but that's very helpful. The other substrate that we're making is, I love it. It works so well. I'm really excited about it, but it really requires a lot of labor. And we're so fortunate to have the cool volunteers coming to help us that we have now. But when you're a volunteer and you help do this type of work, whether it's for us or whether it's for CVF or whoever you're working with, you're helping us out because you're getting more invested in this stuff. Hopefully you're learning more about how all this works. We are probably using your time on our grants. So all the volunteers that work for me, I have to pay match. So if I get a grant, say for $100,000, we probably have to come up with another $100,000 to match it. Okay. Some of that's cash and some of that can be in-kind stuff. And so that can be your labor. If you come work for me and I pretend I was paying you $15, $20 an hour, your time is worth that. And that helps us pay. We basically leverage your work to get more of this stuff done. So not only are you actually physically helping the project, you're helping us to scale the project up more than you even realize. And then you're getting hopefully stoked about it and telling some people about it too, which is a big part of it for us.
Thank you.
Yeah.
All right. Some of those eelgrasses. So one question. I was under the impression that eelgrass was sensitive to our warming waters. Was that just someone's speculation about why we lost eelgrass in the first place? Great question.
Great question. So yeah, the southern end of eelgrass's range is down in North Carolina, and it does not like particularly warm water. It gets really stressed out with a lot of heat. We've had some big eelgrass die-offs in Chesapeake Bay some summers when we've had really warm summers and the water temperature in the bay has gone up really high. We're fortunate here on the seaside where all our eelgrass is growing. We have all these islands and these inlets that carry ocean water on a flood tide in every day. So if our grass starts to get a little bit stressed out from heat in the summer, we know that once the tide turns and starts flooding in, we have all this nice, cool, clear ocean water that's going to help to temper that. So our grass is probably going to be okay. We did not lose our seaside grass because of warm water temperatures. But it could happen. There will probably be a day, hopefully way long after we're all gone, when our eelgrass might be replaced by another more southern species of seagrass. But it's not just heat stress. I'm probably telling you more than you want to know, but you can kind of count on three things that stress seagrasses out. Temperatures, low salinities. Seagrasses like really salty water. So if you have a bunch of storms like we see with climate change, you get a lot of rainwater coming down, you get low salinity stress. And then low light stresses them out too. And low light is maybe you've got a lot of sediment coming in that water, making it cloudy. Maybe you have a lot of fertilizer in the water, so the water's too cloudy because you've got all this phytoplankton clouding it up. And the grasses can frequently deal with one of those stresses at a time. But when you start to have the combinations, that's when you really see the bad die-offs.
Mm-hmm. Mm-hmm. Thank you for that. Oh my gosh, I have so many questions, but I'm going to hold on. Okay, so eelgrasses. So, okay, we talked about like our kind of like environmental stressors. What animals are consuming eelgrasses the most? Is there waterfowl that really? I personally, I think the answer is probably no. Most of our waterfowl that are out as sea ducks, right, are carnivores. But you're the expert. But are there any other species that are nomming away at these kiddos at a high rate?
Right. Not a lot. Most of the year, there's not a lot actually grazing on the grass itself. Any surface underwater grows other things. So we have all these epiphytes, all these little tiny things that are growing on the surface of the grass blades. And there's things that eat those. I mean, the easiest thing to picture is maybe a snail going up and down the grass blade, grazing on that. But there's not much that eats the grass itself. But waterfowl do eat it. Diving ducks like redheads. We have some redheads finally showing back up on the seaside that normally you would only find in parts of the bay with seagrasses. They graze on it, nibble on it. The big grazer is the brant, which I don't know if you know the American brant. It's sort of somewhere between a duck and a goose. Brant were huge here. We had a big hunting industry here before the eelgrass disappeared, and a lot of what folks paid money to come here to do was to hunt brant. And when we lost the eelgrass, we lost the brant, and those guys had to come up with another way to make a living too. We have thousands of brant out there now. They don't hurt the grass. They're really nibbling at the shoots. Vast majority of that grass is underground anyway. They're not ripping it all up. They're eating the leaves. So that's it. The occasional green sea turtle that gets lost is probably, we have a few in Virginia. They're not really supposed to be here, but they would probably be happy that grass was there.
Do you get to see those when you're out on your boat at all? Have you ever been going along and you're like, ah?
Yeah, not greens. Green sea turtles are really rare. We see a few Kemp's Ridleys, but for the most part, we see loggerhead sea turtles. They're not eating the grass. They're eating jellyfish or the crabs that are in the grass. Yeah. But yeah, we get lucky and get to see them too.
I know I get really excited about brant when I see them show up on eBird. Like that is, they're still not popular enough that like you're not like super hyped when they show up. Okay. So is there a grasses for the masses, but for eelgrass? Do you know what that program is? I'm thinking of something that's kind of similar, like you have trout in the classroom or mussels in the classroom. Yeah.
I don't know exactly what grasses for the masses is, and I bet that there isn't. But if you tell me some more about it, I'm happy to.
Well, I was gonna say, well, Nancy might be. Nancy, do you want to unmute and talk, or because I actually am not as familiar with grasses for the masses as you might be, but I just imagine it's like a classroom opportunity for like middle or high schoolers to get to participate or see something in their classroom, and then maybe even say, oh, here, we raised these and let's put them in the wild now.
Meredith has her hand up, so maybe
Oh,
she.
Meredith, yeah.
I think I have an idea what you mean now, but
Yeah, Grasses for the Masses is just the program that CBF ran that is growing wild celery grass.
celery,
though.
yeah.
So yeah, it's basically, yeah, they get people take home a kit and they go and pre-collect the seeds, and you're given seed pods, and then you grow it at home. And then after a certain time, you go out and put it in, like you were saying, wade out into the water and plant it.
Yeah. So that works really well for a lot of species. It's not the best way to work with eelgrass in particular. Although I still think it's maybe worthwhile to grow any type of SAV in the class for kids to learn about it and learn how to grow it, and maybe learn how hard actually it is to grow it. But no program like that. It's really almost entirely seed based, not seedling based. Yeah.
Cool. We have one more predator question. So I actually don't know much about our sea star populations in Virginia and in the Bay. So someone said growing up in Connecticut, that was a major predator of scallops. Further north, do you see a lot of predation for sea stars from sea stars?
Good question though. You know, the only sea stars I've seen here locally are deeper water guys, and I've never seen a sea star in the grass beds. Yeah.
Cool. I have a question, and thank you all who have stayed on, because this is such fascinating. We love learning, so we can teach better. Which species of grass, and this just shows how little I know about seagrasses, and I'm happy to learn about. So as we potentially see warmer waters, what is the species of seagrass that we might see starting to move north, and do we expect eelgrass to move north as well?
Yeah, eelgrass loves cold water, so it can grow north as far as it wants to, as long as there's shallow enough water for it to get light. The next species south is called shoal grass, and that does occur in North Carolina. It's not the same. It doesn't really make quite as expansive meadows as ours does. It grows a little more sparsely, slightly shallower, but that's the next one. And then as you head south from that into Florida, then suddenly you start to have real variety. I'm jealous of those seagrass scientists. They get to play with all kinds of species, but
cool.
Yeah.
All right. Well, both, thank you.
I have one thing I meant to mention, because I'm so excited that sort of a lifelong dream of mine was to be involved with a Sir David Attenborough BBC style nature type show. And there is a new series out. It just aired on Discovery. And I don't know if it's continuing to air on Discovery. If you happen to subscribe to Discovery Plus, you can check it out. It's called The Earthshot Prize, 5-part BBC nature documentary that was started by Prince William. So he sort of introduces each episode. Then Sir David Attenborough sort of sets up each episode with a problem. Each episode has a theme. And then the second half of each episode has a guest speaker to kind of talk about cool things that are happening to fix those problems. I highly recommend the whole series. The name is a little unfortunate. I don't think Earthshot Prize would necessarily make me click on it if I was channel surfing, but good stuff. Episode 4 is on the oceans. David Attenborough sets it up, and then Shakira talks about cool things that are happening. And one of those things that are happening is the eelgrass work in Virginia. And you'll hear Dr. Bob Orth from VIMS talk about it. You'll see some of our volunteers and some of our beautiful Virginia Coast Reserve. So
we'll be sure to share that on social media, just so all the folks that aren't able to, join us on a Saturday night. But that's great. Thank you for sharing that. Oh, can you leave your email? Oh, yeah. Perfect. Ahead of the game. All right.
You won't see me on that, so don't worry about that. I'm driving the stunt boat to keep the cameraman and the drone pilot in the right place, but
that's still an important job.
But you can see better what I'm talking about probably than what we saw on the slides.
Awesome. Well, Bo, thank you so much. I think everyone here really, really was excited and enjoyed learning more about what you're doing. Thank you. And thank you everyone for attending. Yay.
Thanks
Enjoy
for
your
having me.
Saturday.
Thank you all for doing what you do. Keep it up.
Thank you. All right. Yes, Meredith. Happy fall, y'all. Take care.
We'll take care,
Bye.
y'all.
Yeah, thanks,
Bye.
Bo. Don't forget, submit those presentations for 2022. It's right around the corner.
I know. Woohoo. Awesome. Okay.